Hello. Welcome to Lesson 33, the history of the atom and its structure. This is what you should be following along with in the chemistry handout. It's about the 5th page. I'm going to turn that off after and use the board a little bit. What you're talking about here, there's 2 parts to this handout. Part 1 is this, about ancient theories about matter, right? And then we move on to more modern ideas. And then you'll have some questions to do after you read 2 packages. There's actually quite a bit of reading in this lesson with a few questions at the end. So it'll be a 2-day kind of assignment. Let's go back here though. Let's just talk about the most important ideas. This handout is very good. It's very clear to the point. There's not a lot of extra information. The reading packages that you get after have a lot of the extras. But if you want the core knowledge, this is a really good place to look, and this is the part I'm going to work on with you right now. So let's take a look here. Let's see. Historical ideas of matter. So, first of all, we had the ancient Greeks. The ancient Greeks philosophers wondered why matter behaves as it does and manipulated ideas in their minds, but most did no experiments. And that was a big thing about science back then. Is the scientific method wasn't invented yet. There was no testing process to prove ideas, but they did have ideas. I think if you remember back in the electricity unit, if you've done that unit, that some philosophers said, well, if a rock was rubbed, straw would stick to it. That was one of the beginning ideas of electricity. And if you're having theories of electricity, then you must understand what's going on in an atom. So, Empedocles, he proposed that water was composed of 4 elements: earth, water, air, and fire. Now, this is something that you are going to be having just looked at a little bit in the last video in that Mr. Lehan teaches video in the sheet that you just did. So this is still familiar to you. So the first thing you got to know is the ancient Greeks, right? Empedocles thought earth, wind, water, fire, earth, water, air, and fire. There we go. Let's move on down to Democritus, or Democritus, if you'd like. What do you think he had something to do with a name like that? Maybe something to do with democracy as well. That's more of a social studies lesson. But just so you know, in the Greek and Roman times, there were these historically big thinkers. They were famous for coming up with theories for many things. So what does he come up with? At about 400 BC, he suggested matter was made up of tiny particles that could not be broken down further. He called these particles atomos, which means indivisible. So that's where the word atom comes from. So that's something you might want to know, right? Atom means indivisible, which means an atom is the smallest form of matter that we know. One atom has protons, neutrons, and electrons in it. Another thing to understand here is that there was no microscopes. There was no scientific method. That's pretty amazing to be able to think and do logical reasoning by observing the natural world and coming up with this idea that there is a smallest unit of matter and calling it an atom before we had any of the technology to prove it. Amazing. Aristotle. Now, Aristotle, on a side note, if you ever take a literature course, Aristotle is one of the most famous literature theorists about what makes a story, what makes a comedy, what makes a tragedy. This guy right there, Aristotle, wrote a book called The Poetics in English, which gives you an entire logic and reasoning and philosophy about what writing is and what types of writing there are. So once again, another great thinker, democracy, literature. These people are no schlubs, right? They're big thinkers, and this is about 50 years after Democritus. After he died, Aristotle and Socrates, another huge literary philosopher, rejected the atomic model. Oh, no. This is what happens when you let English teachers teach science. Kidding. I'm an English teacher. But they rejected the atomic model. Boo! And they went back to the 4-element model. And this model dominated the scientific thinking for almost 2,000 years. And why did everybody switch? Because there was better evidence? No. Because these people were the big cheese, right? Aristotle, Socrates, these guys know what they're talking about. All right, don't ask any questions, don't challenge them, don't test and experiment. We're just going to believe what they said. Do you understand why learning the history of science is so important? It's so we don't repeat mistakes like this. This is amazing that someone comes up with this, and then because I say so, well, don't get me started, they just took the better idea and went back to an old one for no reason. So, boo. Then we move on. Let's keep flipping here. All right, and then came the alchemists. The alchemists were the first people to perform experiments hands-on. They were part philosopher, part magician, part chemist. I'm going to turn off the projector for now. All right. There we go. They believed that some elements could be changed into others. So what I want to tell you about the alchemists, really the big thing you've got to know about the alchemists, they were kind of like a mixture of scientific ideas and wizards. Because their whole goal was to turn normal things into gold. Yep, that's right. They were trying to turn things into gold. So they were kind of doing witchcraft. But in the mix of this like hocus pocus, they kind of were the first people to do like experiments and scientific theory and the scientific method. So out of this kind of crafty, clever witchcraft, they actually kind of started developing some of the backbone of scientific inquiry and methods. So look at them. What would I write for a shorthand note for, let's go and like do a quick summary of these people here. I wrote it down here. In your pack, I wrote, right, what would you say for a summary of Empedocles? I would say his biggest thing was the four-element theory. Democritus, I would say his biggest contribution was the atom. And then I would say Aristotle and Sophocles. The other things to remember about them is that they sent back science a bit because they switched models. That brings us to the alchemists. And how would we summarize the alchemists? I would say the biggest things to remember about them, kind of like witchcraft plus science. They wanted gold, and they used first experiments. Just so you have kind of a summary of them, right? They believed that elements could be changed into others. They attempted to change these base metals into valuable ones like gold, but in the process discovered new elements as well as many facts about existing materials. Pretty cool. They believed they could find a substance that would give them eternal life. Okay, that's just awesome. So this was like one of their big goals. We will find a substance that will make us live forever. All right, cool. They believed they could produce a universal solvent that would dissolve any substance. These people were nuts. I love it. I love it. Then we get into kind of the more modern chemists, right? And now we're going to have a list of them. If you look at the PDF that I gave you, it's actually missing these pages. It scanned it incorrectly. But the handout that you have has it, so no worries there. The modern chemists, 1600 to present, these chemists used scientific method to investigate the physical world. This began in the 17th and 18th centuries, where the focus was on determining the properties of pure substances and attempting to explain their composition. Sir Francis Bacon, he was one of the first scientists to develop new knowledge to use by using experimentation. Robert Boyle believed that the four-element theory could be improved upon. That's huge. He changes it up. And Bacon was known for experimentation. I'm going through these quickly because they're not super crazy important for you. He published The Skeptical Chemist, in which he defined an element as a certain simple, unmingled body. Boyle also helped lay the foundation for the concepts of elements as compounds. He recognized that elements can be combined to form compounds. That's a huge deal. Boyle also believed that air was not an element, but a mixture. Here comes Joseph Priestley. Priestley was the first person to isolate oxygen scientifically, but did not know that oxygen was an element. Then we move on here to Lavoisier. Lavoisier defined the term element as a pure substance. He discovered and identified 23 elements. That's going to be bringing us to kind of the beginning of the periodic table. He recognized mixtures and mixtures exist and identified air as a mixture of oxygen and some other gas. Air is at least two gases, one that burns and one that does not. So he realized that. And then this is kind of cool. Cavendish kind of took this oxygen idea, right, and water idea. Watch what he does here. Cavendish experimented by mixing metal with acid. So he took metal and acid, and it made a gas that he could light on fire. And part of when he lit that on fire, what would be produced was water. Up until that time, if you read here, until that time, water was thought to be an element. They thought water was like copper, gold, lead, mercury, water. No, because he did an experiment and made water, which means water must be at least two things. And we know that water is hydrogen and oxygen. So now we're going to get into the next major part, if you look down here. And this is kind of a little bit, I don't know if I want to say better, but this is more of what you're going to actually need to know. Especially on a test, this is like a very standard test question where you've got to take these four people and compare their ideas. So now what you're going to do is, what I would like to explain to you is basically, you're going to have four people, right? You're going to have Dalton, Thomson, Rutherford, and Bohr. And then at the last page, we also have Einstein. But we're not going to get too much into that because, well, he's Einstein and we're not. We'll do a little bit. But you need to understand Dalton, Thomson, Rutherford, and Bohr's four models. Because, you know, Dalton comes up with one idea. And then after a little while, Thomson expands on it. And he comes up with a new idea. And then Rutherford comes up with a little bit of a change. And then Bohr comes up with a bit of a change. And we use Bohr's theories to this day. So what we're going to do is we're going to look at how four different scientists over the course of a couple hundred years grew, used experiments, which is very important, and actually proved and improved scientific theories on what an atom is. So let's look at the Wayback Machine first and see what Dalton said here, right? So Dalton's theory was in the early 1800s. He called his theory the billiard ball model, and that's important. Dalton proposed the following. An atom is solid, indivisible, indestructible sphere. The atom contains no subatomic particles. He was wrong about that, right? But Dalton's atomic theory, all elements are composed of atoms. Atoms are indivisible, indestructible. Atoms of the same element are exactly alike. They all have the same mass and chemically behave the same way. Kind of true. Each element is characterized by the mass of its atoms. Different elements have atoms that differ in mass and chemical properties from the atoms of every other element. Atoms of different elements are different. The joining of two atoms or more can form a compound. That was pretty cool. And atoms are neither created nor destroyed in a chemical change. He was actually pretty right about that. So he said you could take hydrogen and oxygen and make water, but it's still hydrogen and oxygen. They don't change. He was right because you could actually separate them. So his idea, Dalton, he was called the billiard ball. And he basically thought, okay, this is what an atom is. It's a solid chunk, right? Like a pool ball, a billiard ball. So hydrogen would all be exactly the same, right? Maybe oxygen would be this big, right? You could put oxygen, carbon, nitrogen. He said every atom was just one chunk. There was no particles in it. There was no protons, neutrons, and electrons. That hadn't been discovered yet. This is what he believed. But he did believe like hydrogen would be different from carbon, which would be different from... So he had an idea. And this was a very popular theory. So he was the first one. He came up with the billiard ball model, and you're going to need to know that for a test. Now comes Thomson, and let's see what Thomson does. So I'm going to write that down there. Number 2 would be Thomson. You could write this down if you want or not. That's fine with you because you're going to be seeing it a lot, but you do need to know this. This is on tests. This is on exams. These are things that you need to understand. So Thomson's model, he called it the raisin bun model. Okay. Why do you think that? Because basically he pretend this is the raisin bun, he found raisins inside of it, or protons, neutrons, and electrons. I'll get into it right away. Let's take a look here. The model that resulted from Thomson's theory is referred to the raisin bun or plum pudding model. Thomson experiments with a Crookes tube while he was studying the passage of electric current through a gas. This led to his discovery of a very light negative particle called electrons. This disproved Dalton's theory that an atom was indivisible. Thomson further experimented with gas discharge tubes, which led to the discovery of much heavier positive particles, later identified as proton. So basically, he was experimenting with gas in tubes and passing electricity through them, and he realized that there must be protons and there must be electrons. He also realized the protons are heavy. You don't need to know that. You need to know that he had the raisin bun model, and then these next points here are very important, right? He came up with the idea that electrons have a small mass and a negative charge. An atom is a sphere of positive electricity, and negative electrons are embedded in it. Well, Thomson, you did discover electrons, which is very key, right? You did not discover, but you had it wrong. But let's look at his theory, the raisin bun model. He thought an atom was a positive area, right? The whole thing was positive, but inside, electrons were buried inside of it. So he thought the entire thing was positive. Overall, positive with negative electrons embedded like raisins in a bun, right? Now remember, look up here. We know now, just to refresh your memory, that an atom really is lots of electrons flowing around in orbits with a very small nucleus where it's positive and protons and neutrons are there, and the electrons float around like that, right? This is what an atom really looks like. Don't get confused. This is what Dalton thought it was. This is what Thomson thought it was. And then this is what it really is, and we're going to get to that eventually, okay? So now we move on to the second last major contributor, and we look at Rutherford. And Rutherford comes up with some cool ideas here. Rutherford's model that resulted is called the nuclear model. So we'll write that down. So the nuclear model, what do you think he discovered if we're talking about a nuclear model? What part of the atom do you think he discovered? The protons or the electrons? No, he discovered the neutrons. So you can kind of put together where this is going. Rutherford attempted to test Thomson's model with radioactivity in an experiment using gold foil and a type of radiation he called alpha particles. He discovered the existence of a dense positively charged core in the atom of the nucleus. Rutherford proposed the following. The nucleus is a very tiny, dense, and positively charged core of an atom. All of the atom's positive charged particles are called protons, are contained in the nucleus. The nucleus is surrounded by mostly empty space, and rapidly moving negative charged electrons are scattered around the outside. Wow! This is pretty good. So he didn't actually come up with neutrons. He came up with the nucleus. My bad. So he came up with this idea. He came up that an atom had a nucleus. This was his big idea, right? That was positive. And then it had electrons floating around on the outside. So that was his idea. Now we get to the last theory here, Bohr. And Bohr is what we use now. I'm not trying to bore you. But this is really important. And Bohr kind of takes all of this and he gets it to where we kind of use it today. So Bohr. And Bohr is what we use now. Oh, by the way, if you want to look up Rutherford gold foil experiments where he's shooting particles through foil, it's actually pretty fascinating. I might be able to find a video for you later to explain that. But you need to know that he came up with the nucleus, right? Nuclear model means he discovered a positive nucleus. Cool. So Bohr has the planetary model. And this one puts it all together, right? Bohr proposed the following. Electrons move around the nucleus in nearly circular paths called orbits, much how the planets circle. Each electron in an orbit has a definite amount of energy. Electrons can move within these energy levels without the loss of energy. The further the electron is from the nucleus, the greater the energy. Electrons cannot exist between orbits. Each orbit or energy level is located at a certain distance from the nucleus. Electrons are more stable when they are at lower energy levels closer to the nucleus. The order of filling the first three orbits with electrons is 2, 8, and 8. Whoa, boy. Okay. So he came up with the idea that the middle of an atom is positive and that, let's say I have 5 protons in the nucleus here. That means how many electrons am I going to have? Protons and electrons always equal. So I have 5 electrons. Well, he said that electrons kind of orbit around like planets around a sun. And he also said the level for the first rings are 2, 8, and 8. I don't even know what that means. What are you talking about is what you're thinking right now. Okay, well, if there's 5 protons in this atom that we're making up, how many electrons would there be? 5. So how would I put them? Well, the first ring of planetary kind of electrons, it's only allowed to have 2. So I could put an electron and an electron. Okay, that's kind of cool. But I still have 3 more electrons I could place. So I've got to draw another ring a little bit further. And I've got to put those last 3 there. Don't worry, you're going to have a lot of practice doing these right away. This is just a warm-up, kind of. So, basically, you could see a positive nucleus with electrons in orbits. And some of his theories down here, if you look, right, he said that the electrons that were closer to the nucleus were more stable. You couldn't rip those away. You couldn't get rid of them. You couldn't move them. He said you could put 2, 8, 8, and then there's more rules as we go on. We'll get into that later. But he said that the atoms, or the electrons in the last ring, whatever your last ring always is when you're drawing your model, which we will be doing later, don't worry, I'll explain it better. When you draw your models, the last ring are the ones that you can actually play with. They're less stable. So we'll talk into that, but you need to know these 4 theories. So this brings you to your basic assignment. And what you need to do is you need to read 3.2 in your package. And right, it talks about the Greeks and Aristotle. It kind of gives you a nice review. It talks about alchemists and things like that. And then you're going to get to this page right here. And you are going to do, my bad, I'm going to remove this. You need to do 1, 3, 4, 5, and 6. There you go. So you need to do those. You can skip 2 actually on, I guess it would say here, page 85 of the book, which isn't really page 85, you know that. And then you also need to read this handout called Atomic Theory, which kind of does the same thing, explains it in slightly different ways. It talks about some of the ideas about matter, theories and laws, and Dalton, Thomson, And of course, you'll talk about Rutherford, and this gives a lot of information about his gold foil experiment. And then you'll talk about Bohr, who is actually the person that we use the most often, right? And of course, on this section, you will do questions right here. It says 29 at the bottom if you want. On the reading check section, you will do 1, 2, 6, and 7. So when you're done with all that, you're going to take pictures of those questions and you're going to submit them to me for assignment 33. And now we're going to move on to just looking at Bohr diagrams and the development of what we call right here, remember, the periodic table. How was that made? That's coming up next. So we'll see you soon.